Okay.
Yes, sir. Sawan sir, you can start.
Okay. Thank you, sir. Good evening, all. Today, on 7th September 2011, I, Professor Raghunath Sawant, working as Assistant Professor in Department of Geography, SP College, Pune, would like to greet and welcome to one and all in this afternoon second session of PhD coursework, which is organized by Department of Geography, SP College, Pune. It is my honor and privilege to introduce very prominent and distinguished academician, Dr. Uttam Pawar sir. So we are very fortunate to have such a great and multidimensional speaker with us today. Sir is presently working as an assistant professor in Department of Geography, HPT Arts, ROIK Science College, Nashik, since last 11 years. Sir has completed his master's in geography. Sir has also qualified B.Ed, NET and SET also. Sir has done his PhD on an analytical study of geomorphological, hydrological, and meteorological characteristics of floods in Mahi River Basin, Western India. His area of research interests include flood geomorphology, flood hydrology, and flood hydrometeorology. Moreover, Sir has published and present more than 5 research papers in national and international publications and conferences. So, without any further delay, I request to you, sir, share your thoughts and expertise on today's topic, process of Indian monsoon. Over to you, sir. Thank you very much.
Thank you, sir. So my screen is visible.
नाही सर स्क्रीन नाही दिसत आहे.
Now is it visible?
येस सर येस.
Shall I start, sir? Hello. Hello.
Yes, sir. Yes, sir. Now it is visible.
Yes, sir. Please start.
Okay. Thank you, sir. Good afternoon, all participants, and welcome in today's session on processes of Indian monsoon. The key focus of today's lecture are monsoon, its meaning, origin, and mechanism, factors influencing Indian monsoon, monsoon trough, its meaning and its position, weather forecast, meaning and types, synoptic conditions and rainfall, global teleconnection, there is El Nino and La Nina, monsoon 2021, and methods for rainfall data analysis. So these are the 8 key focus points on which today I am going to discuss with you. First, discuss about what is monsoon. Since the monsoon is very complex natural phenomena and it is very difficult to understand still the nature of monsoon. So let's first discuss about the monsoon. The word monsoon is derived from the Arabic word for season, and the distinguishing attribute of the monsoonal regions of the world is considered to be the seasonal reversal in the direction of the wind. The monsoonal region, delineated on the basis of significant changes in the wind direction between winter and summer, extends over a large part of the tropics, namely 25 degrees south to 35 degrees north latitude and 30 degrees west to 170 degrees east longitude. There are two maps that shows the global monsoon regions. The first map, which was defined by Ramsey in 1971. According to him, there are three major global monsoon regions, and they define East Asian monsoon region, North American monsoon region, and South American monsoon region. In 2011, these regions were redefined by Wang et al., and they identify 8 monsoon regions all over the world. First one is EAS, which stands for East Asian Monsoon Region. WNP, that is Western North Pacific Monsoon Region. RND, Indian Monsoon Region. NAF, North African Monsoon Region. NAM, that is the North American Monsoon Region. SAM, South American Monsoon Region. SAF, South African Monsoon Region, and this is the Australian Monsoon Region. There are four main areas of the monsoon climatic region, but here I have considered only out of them two major, which are widely observed all over the world, and they are divided as a true monsoon areas and pseudo monsoon areas. True monsoon areas, which includes countries like India, Burma or Myanmar, Pakistan, Bangladesh, Thailand, Cambodia, Laos, North and South Vietnam, China, Philippines, and northern coastal areas of Australia. Whereas in pseudo-monsoon areas are found along the southwest coast of Africa, which includes the coast of Guinea, Liberia, and Ivory Coast, Eastern Africa, and Western Madagascar. Now, what is pseudo-monsoon? In some countries or regions, the monsoon winds, which flows continuous and regular in one season of the year and are absent in opposite season, or do not flow in the opposite direction but flow in the some other direction, called as pseudo monsoon region or tendency of monsoon wind. What causes monsoon? The primary cause of monsoon is the difference between annual temperature trend over land and sea. The apparent position of sun with reference to earth is not fixed. It oscillates from Tropic of Cancer to Tropic of Capricorn through the equator. The heating leads to the creation of a low pressure region. Second, the northeast and southeast trade winds converge in this low pressure zone, which is also known as the intertropical convergence zone, that is ITCZ. This low pressure region witnesses continuous rise over the moist wind from the sea surface to the upper layer of the atmosphere, where the cooling causes the loss of moisture resulting in precipitation. It is observed that the rainy season of East Asia, Sub-Saharan Africa, Australia, and southern part of North America coincide with the shift of ITCZ, that is intertropical convergence, towards this region. The next is Indian monsoon. Now here I am going to discuss about particularly the Indian monsoon climate introduction. The southwest monsoon in India runs from the June to September, and rainfall during the southwest monsoon accounts for about 70% of India's total annual rainfall. The monsoon is also an integral part of India's economy since farming makes up 15% of India's GDP and employs more than half of the population. As we know that the economy of the India is based on agriculture, and agriculture is most of the areas of India is based on the monsoon rainfall. So in addition to this rainfall determining yield for crops such as rice, wheat, sugarcane, and oilseeds, it also helps replenish reservoirs and groundwater for irrigation as well as boost hydropower production. So no doubt, besides the agriculture, hydropower generation and groundwater also affected by the monsoon. Then there are certain criteria on the basis of which IMD declares every year onset or the arrival of monsoon and advance of the monsoon. And out of this, first criteria is the rainfall. If after 10th May, 60% of the available floating stations which are enlisted by the India Meteorological Department, and these are from the Lakshadweep, Kerala, and one from the Karnataka. It includes Minikoi, Amini, Tiruvananthapuram, Kollam, Punalur, Alapuzha, Kottayam, Kochi, Thrissur, Kozhikode, Talasari, Kannur, Kudulu, and Mangalore. So when this station receives 2.5 or more rainfall for 2 consecutive days, the onset over Kerala be declared on the second day. But there are two more criteria that also should be fulfilled. Then only it is declared by IMD on that monsoon is reaching India or the arrival of monsoon in India. These two criteria are the wind field depth of westerly should be maintained up to 600 hectopascal in the box equator to latitude 10 degree north and longitude 55 degree east to 80 degree east. The zonal wind speed over the area bounded by 5 to 10 degree north latitude and 70 to 80 degree east longitude should be of the order of 15 to 20 knots at 925 hectopascal. So there should be wind speed 15 to 20 knots, and again the pressure 925 hectopascal. And third criteria or the parameter is outgoing long wave radiation, that is OLR. Insect derived OLR value should be below 200 watts meter per square in the box confined by 5 to 10 degree north latitude and 70 to 75 degree east longitude. Then there is one more concept related to this, northern limit of monsoon. Southwest monsoon normally sets over Kerala around 1st June. It advances northward and covers the entire country around 15th July. The NLM, that is the northern limit of monsoon, is the northernmost limit of monsoon up to which it has advanced on any given day. This is the map of onset and advance of southwest monsoon 2021. The red line on the map represents the normal dates of onset, and blue line represent the actual dates of onset. For example, in Kerala, normally monsoon arrives at 1st June, whereas at Mumbai it is say 10th June, and the northeastern part it occupies almost about the 8th July. But actual onset of the monsoon is represented by blue color line. It indicates the arrival of monsoon in Kerala for 2021 monsoon season is 3rd June. Then it covers the area of the Goa state around 4 June, which is a day before of the normal onset of the monsoon in Goa state. And if we take the extreme northwest part of India, where the normal dates of the onset of monsoon is 8 July, but actually the north monsoon of 2021 reached in this region on July 13th. So it is delayed up to almost 5 days. So thus represent the arrival of monsoon and its advance or northernmost limit of monsoon for the monsoon season 2021. Now, next point is the factors influencing southwest monsoon. There are several factors that affect the monsoon origin, its process. However, I have considered here three factors on which I'm going to discuss next further points. So the first point is the differential heating and cooling of land and water that creates a low pressure on the landmass of India while seas around experience comparatively high pressure. So this is very well known to us that during northern summer, when the sun is in the northern hemisphere and Indian landmass and adjoining land area gets more uh, incoming solar radiation, and that cause there is increase in temperature. And as we know, there is inverse relationship between the temperature and the atmospheric pressure or air pressure. So because of the high temperature, there is the expansion of the air which creates the low pressure area. So on the other hand, because of the apparent of the sun in the northern hemisphere, at the southern hemisphere, where over the Indian Ocean, there is low temperature that creates the high pressure area. So this is because of the heating and cooling of the land and water. Second thing is the shift of the position of intertropical convergence zone in summer. Normally, the IT cell is located between 0 to 5 degree north and south of, but with the apparent migration of the sun, it shifts 5 degree north and south. So during summer season, it shifts towards the north of its normal position. Over the Ganga plain, equatorial trough normally positioned about 5 degree north of equator, and it is known as the monsoon trough during the monsoon season. And third, southern oscillation. Normally, when the tropical eastern South Pacific Ocean experiences high pressure, the tropical eastern Indian Ocean experiences low pressure. But in certain years, there is a reversal in the pressure conditions, and the Eastern Pacific has a lower pressure in comparison to the Eastern Indian Ocean. And this periodic change in pressure condition is known as Southern Oscillation or SO. First, discuss about the thermal concept related to the origin of the Indian monsoon. or the monsoon. The traditional idea of monsoon formation was developed in 1686 by English astronomer and mathematician Edmund Halley. So according to this thermal concept, after spring equinox, that is March 23rd, the sun starts its apparent northward shift. As a result, the areas which are located north of the equator, mainly the tropics and subtropics, get a progressive high incoming solar radiation. And because of this high incoming solar radiation, intense heating of the vast northern plain and the adjoining highlands, here we can add the Tibetan highland also because it is a very extensive highland plateau area and which is get heated during the summer monsoon and creates the low pressure area. As a result, a massive low pressure trough is formed and that extends from the Punjab plain in northwest to the Bengal Delta in the east. The level of solar radiation that reach on the India or landmass that is high during the May and June, and the pressure gradient between this low pressure trough and the adjoining sea is so great that it attracts wind from as far as south of the equator. The development of some high pressure centers in the Indian Ocean, Arabian Sea, and over Australia because it is beginning the winter season in Australia since the position of the sun is in the northern hemisphere and that's why the Australia the winter season. The wind pattern which are prevalent south of the equator are actually the southeast trade winds, which blows from the southeast towards the northwest, and this wind attracts by low pressure trough over the Indian subcontinent. While moving north of the equator, these southeast trade winds they turn in a clockwise direction, or we can say towards the right, following Farrell's law. The shift in direction is brought about by the Earth's rotation. Now, the original southeast trade winds become southwest monsoon blowing towards the northeast. Here, although the direction of wind is mentioned from southwest to northeast, but actually direction of the wind is always decided from which direction wind is blowing, not to going to in which direction. So most of the wind, southeast trade winds, it means winds blowing from southeast. Northeast trade winds means winds blowing from northeast. So direction of the wind is depend upon the from which direction wind is blowing. Then the southwest wind now approaching the Indian peninsula have to travel a long distance over Indian Ocean. The southwest monsoon which get divided into the Arabian Sea branch and Bay of Bengal branch because the shape of India, southern India is peninsula. Their moisture-laden winds cause heavy rainfall on the windward side. So in this map, we can observe this is the peninsular shape. The peninsular shape, it means the landmass which having water body from three sides. Okay, so because of that, the southwest monsoon branch divided into two. That is one branch occupy the Indian territory from the over the Bay of Bengal and second branch over the Arabian Sea. Here two images that shows the movement of the monsoon winds during summer monsoon season and winter monsoon. So here in summer season, low pressure form over the Indian territory or Indian landmass, and because of the low pressure system, low pressure form over the India and high pressure over the Indian Ocean. So winds blowing from ocean towards the Indian landmass. So vice versa during winter season. So during winter season, there is a formation of high pressure and low pressure form over the Indian Ocean and Asian area. So winds are blowing from the Indian subcontinent to the towards the Indian Ocean. These winds are dry since they are blowing over the Indian landmass, but when they flow over the uh, uh, Bay of Bengal, they pick up the moisture and then some amount of rainfall observed the coastal area of the Tamil Nadu, Andhra and Kerala. The next is northeast monsoon. By month of September, the land begins to rapidly cool off as the sun moves into the southern hemisphere. Since the Indian Ocean is the last to get heated during this retreat, the high pressure created from the rapidly cooling landmass and that cause winds to blow southward. Cold winds from the Indo-Gangetic Plain sweep to the south of the Deccan Plateau, once again pick up moisture off the Bay of Bengal and delivering rain to the eastern Ghat along the Kanyakumari and Coromandel coast. This map shows the normal dates of withdrawal of monsoon. Just like onset dates of the onset of monsoon, the, the monsoon start to withdraw from the northwestern part of the India. So in case of onset of monsoon, it reaches around 15th of July, but it's retreat early from the northwest part around 1st September. Then we can observe here that up to the 15th of October, almost northern and central part of the India monsoon retreat. And after 1st of December, entire the Indian uh, landmass, uh, there is no monsoon condition. There is whole retreat of the monsoons over the Indian territory. And there is one more important concept about the monsoon trap, and it has very important or significant role over the rainfall distribution and its intensity. First, discuss about what is monsoon trap. A trough is a belt of low pressure extending to large area. It's simply the low pressure. This trough seen during monsoon period and hence known as monsoon trough. This is normally shown as a line connecting the location of monsoon low pressure areas. This trough run across continents during peak monsoon periods. Then what are the features of this monsoon trough? The first one is this trough is located in east-west direction from northwest Rajasthan till the Bay of Bengal. Secondly, the height of trough extends up to 5.8 kilometers upward in the atmosphere and it tilts southward with height due to the temperature difference of 2 degrees Celsius with height. Whenever a low is formed in Bay of Bengal on east coast, it enters in the northwest direction. Then it follows the path of monsoon trough line, giving very good rainfall in the southwest sector. The position of the monsoon trough and the intensity of low affects the rainfall activity over various parts of India. There are three positions of the monsoon trough. First is the normal position In second position, the trough line shift south of the normal position, and in third situation condition it shift north of the normal position. So first, discuss about the normal position. What do you mean by the normal position of the monsoon trough? Normal position of the monsoon trough means it passes through Ganganagar, Allahabad, Kolkata, and head bay, that is uh, head part of the Bay of Bengal, and it gives good rain to central India. As a effect of low formation and its passage along the trough, the strong wind currents from over the west coast. These currents are blocked by Sahyadri Mountains, resulting in formation of offshore trough. Hence, due to the offshore trough in the west of India coastal area, the western part of the India receives good monsoon. In this image, we can see this the circle filled with purple color represent the location of the low pressure systems that moves northwest direction, formation of the low pressure system over the Bay of Bengal, and northwestward movement of these systems. And this is the normal position. So this low pressure system follow the normal path of the monsoon trough, and this red color box and second red color was the west coast of India. Both represent the areas where there will be good amount of rainfall, and this line represent or the Arabian Sea represent the offshore trough. So whenever there is offshore trough, the coastal area also receives very good amount of rainfall, and the normal position of the monsoon trough changes either southward or northward. So now discuss about the second condition when there is shift of now monsoon trough towards the south. So south of the normal position, when the trough shift to the south of its normal position, the monsoon conditions are active and giving excessive rain over the central India and over the west coast of India due to the formation of offshore trough. And this position is best for monsoon condition giving in all over the peninsular India. And this situation is now create. That's why in next 2 3 days there will be a very good amount of rainfall over the entire Maharashtra, Madhya Pradesh, Telangana, then parts of the Gujarat and Rajasthan. So here we can observe that the this is dotted red color line. It is the position of the normal monsoon trough. Now the trough is shifted southward and the low pressure system follows the path of this monsoon trough line. And there is the offshore trough, monsoon trough over the Arabian Sea, and because of that, the entire coastal area also receives good amount of rainfall. Normally, this trough is located from southern part of Gujarat, or we can say the South Gujarat to the Kerala, or sometimes North Kerala to South Gujarat. The next is the north of the normal position. So here, this is the red color dotted line represents the normal position of the monsoon trough line, and this represents the shift of monsoon trough towards the north. When the trough shift to north of normal position, it means it shifts to foothills of Himalayas, giving good rain to Uttarakhand, Himachal Pradesh, Jammu Kashmir, and to all northeast states of India. And this condition is known as break in monsoon because rest of the India the rainfall activity stop. So whenever over the southern part of the India or central part of the India, there is no rainfall. It means that there is a north shift of the monsoon trough, and the rest of the country there will be no rainfall activity. And this condition we observe every year during monsoon season, and this year also the condition was prevailed there. Then offshore drop. This is one more important concept, and this is also responsible for the rainfall distribution. During the monsoon season, a shallow trough of low pressure is observed along west coast of India. This is known as offshore drop. This type of system quite frequently develop off the coast of India, anywhere from North Kerala to South Gujarat during the period of southwest monsoon, and is responsible for strengthening of the monsoon in terms of rainfall in the adjacent part of the coastal belt. So the here L stands for low, formation of the low pressure system. C stands for the cyclonic circulation, and these are the trough lines, and this is offshore trough over the Arabian Sea. Now the next important point is the weather forecasting. What is weather forecasting? And the term is very well known, that the forecasting means the process of estimation of or the prediction of the value of some variable at some future time. Here, in case of weather forecasting, the weather parameter or the elements of weather and climate are considered, that is the rainfall, temperature, wind, humidity, and etc. And on the basis of there will be prediction or estimation of the weather for different time period, ranging from the short to long range forecast. And depending upon this time span, the weather forecasting is of four types. First one is now forecasting. So whenever there is forecast only for few hours, but it should be less than 24 hours, then we can say no, now forecasting. Second type is the short range weather forecasting. Whenever the weather is forecasted up to for 72 hours, then it is short range forecasting of the weather. Medium range forecast, it is valid only for a period of 4 days to 10 days, and long range forecast from 30 days up to one season. So for example, forecast for monsoon 2021. So this is long range for entire season. This is one example related to the weather forecast, and these maps obtained from the windy, which is weather application, Android application. And here we can observe there is a formation of L. L stands for low pressure over the Bay of Bengal, and where there is 1,300 hectopascal pressure for the 6th September 2021. Now, if you see the second map, which is predicted weather system for the 9th September 2020. So this low, which is formed over the Bay of Bengal, and which is shown in 6th September map, now shift in the central India. And then there is one more formation of the low system over the northeastern, northwest part of the India and adjoining Pakistan. So when we join this low pressure area by the line, that is called as the trough line, and this is the low pressure area. So again, there is offshore trough line, and this this yellow color line represents the normal position of the monsoon trough. So here we can observe that the current at current situation, low pressure or low trough line is shifted towards the south of the normal monsoon trough line, and that's why in next 2-3 days there will be good amount of rainfall over the central and south part of the India. And yesterday we have seen there was heavy to very heavy rainfall over the parts of the Marathwada and Vidarbha region, and the rainfall activities will going on increasing as the this system moves further northwestward. So this is for the 9th September 2021. Then this is also the forecasted weather map, which I have obtained from the Regional Meteorological Center of Mumbai. And for the same period, that is for 6th September, 7th September, and 8th September 2021. Here they have forecasted weather for different sub-climatic regions of Maharashtra, uh, mainly the East Vidarbha, West Vidarbha, Marathwada, North Madhya Maharashtra, South Madhya Maharashtra, North Konkan, and South Konkan. So they have denoted different forecasts by different code words, that is WS, FWS, SCT, ISOL, dry. So WS means widespread rainfall of over the particular climate subclimatic region. Then FWS, it means the fairly widespread rainfall. SCT, it means scattered. ISOL, isolated and dry. So in this map, we can observe that for the day 4 and day 5, that is on 7th September and 8th September, the INVA has predicted the widespread rainfall over the all subclimatic regions of Maharashtra, or in other words, for whole Maharashtra. Now this WS, FWS, SCT, ISOL have some specific values on the basis of IMD use this word more precisely. And these are the widespread. So when it is said widespread, when the 75% or more number of stations of a region, usually a meteorological subdivision, reporting at least 2.5 millimeter rainfall. So for example, in the previous map, if you want that IMD has shown widespread rainfall for the Vidarbha region or Marathwada region, it means the whatever the rainfall stations available in the Marathwada region, so all the 75% or more stations, they should reporting at least 2.5 millimeter rainfall. Then fairly widespread, it means many places there will be rainfall. 51% to 74% number of stations of a region reporting at least 2.5 millimeter rainfall, then only the fairly widespread rainfall we can say. Then scattered, it means at some or few places. And according to IMD, when 26% to 50% number of stations of a region reporting at least 2.5 millimeter rainfall, then it is said that scattered rainfall. Isolated, it means isolated at places. 25% or less number of stations of a region reporting at least 2.5 millimeter rainfall, and mainly dry, it means no station of a region reported rainfall. So likewise, there is also some amount of rainfall given to particular rainfall intensity by the IMD. Now we normally heard in the news the अति मुसळधार पाऊस किंवा हलका ते मध्यम स्वरूपाचा पाऊस, पण exact amount of rainfall is not known most of the time. So IMD has given some amount of rainfall, particular intensity of rainfall, and that amount of rainfall should be occurred within 24 hours or in a day. So no rain means 0 millimeter rainfall. Whenever there is 0.01 to 0.04 millimeter rainfall, then we can say the trace rainfall. Very light rainfall whenever there is a rainfall amount between 0.1 to 2.4 millimeter. Light rainfall, its rainfall value ranges between 2.5 to 7.5 millimeter. Moderate rainfall rainfall value varied between 7.6 to 35.5 millimeter. Rather heavy rainfall value between 35.6 to 64.4 millimeter. Heavy rainfall between 64 to 124.4 millimeter. Very heavy rainfall between 124.5 to 244.4 millimeter, and extremely heavy rainfall more than or equal to 24.4 millimeter. So exceptionally heavy rainfall, whenever there is rainfall amount exceeds 12 centimeter, then it is called exceptionally heavy rainfall. And one more concept is meteorology, that is rainy days. When a day at a particular ranger station 2.5 millimeter or more amount of rainfall is recorded, then it is called a rainy day. So second aspect that affects the intensity distribution of rainfall, synoptic conditions. The tropical disturbances formed in the Bay of Bengal and the Arabian Sea and over the land point in the central India, known as low pressure system or LPS. These depressions, like other tropical disturbances, move westward or northwestward, having a life cycle of 3 to 5 days. The heavy rainfall is confined to a belt of 400-kilometer wide and 500-kilometer long to the left of the track of LPS. It gives widespread heavy to very heavy rainfall in the southwest sector of the LPS. So here we have used the word widespread. So with the help of earlier discussion, you can understand now what is widespread rainfall and what is the heavy to very heavy rainfall, because these are the qualitative statement. So in order to understand the meaning of this, we should know the exact quantitative data of it. Amount of rainfall goes up to 300 to 400 millimeter in 24 hours at a particular range station. So again, these are the synoptic conditions uh, defined by the India Meteorological Department. And then meaning, so cyclonic circulation means the atmospheric wind flow in upper levels associated with any low pressure system. When we call low pressure area, it is depend on the wind speed. Whenever the wind speed is less than 70 knots or in kilometer per hour, 31 kilometer per hour, then we say at the sea, then we say low pressure area. So again, the intensity. Now the following are shows the uh, increasing intensity of the low pressure area depending on the wind velocity and the close isobar. Now depression means it is close 2 to 3 isobar having 2 hectopascal interval and wind speed from 17 to 27 knots at sea. The further intensity of this is the deep depressions. 2 to 3 close isobar at 2 hectopascal interval and wind speed from 28 to 33 knots at sea. Then cyclonic storm more than 4 close isobar at 2 hectopascal interval and the wind speed on surface level is in between 34 to 47 knots. It means the wind speed increasing. And if you see the super cyclonic storm, it is encircled with slow 4 isobars at 2 hectopascal interval, and the wind speed on the surface level is about 120 knots or 222 km per hour and above. This is one example I have taken from my research area. That is the this is Mahi Basin, and this is the mean track of low pressure system, which have been derived on the basis of long record of the low pressure systems, say more than 100 years, and this mean track obtained. So this is the mean track of that affects the rainfall of the Mahi Basin and thereby the floods, Bay of Bengal track, and this is the Arabian Sea. So all the Arabian Sea track that goes in the Mahi Basin, but this could not have produced heavy rainfall or floods in the Mahi Basin. Then next, this is one case study that in the Mahi Basin on record so far in the last century, or we can say that till date, the heavy rainfall occurred and the large flood occurred on because of the 26th August and September 2nd September 1973 low pressure systems, and which caused the flooding in the Mahi Basin and high discharge recorded in the Mahi Basin at Banakburi. Here we can observe that the first low pressure system developed over the Bay of Bengal on 26th August 1973, and this track goes the northern part of the Mahi Basin that affects the rainfall over the Mahi Basin. But this track or the low pressure system caused there was no flood, but the consecutive the followed this low pressure system, there is second one more low pressure system developed on 2nd September, and this low pressure system created a large flood in the Mahi Basin because this previous low pressure system caused there is heavy rainfall and everywhere moisture conditions are present. Because of the presence of antecedent moisture, this low pressure system of 2nd September creates heavy rainfall in the Mahi Basin. So these low pressure systems have the capacity to create the floods or flash floods. So here I have taken the map of the low pressure system that produce the rainfall over the entire Mahi Basin for the 3 days, that is August 31, 31st, 1973 and 1st September 1973. So most of the basin having widespread rainfall. And second map is of the second low pressure system that is from 7 to 9 September 1973. And here we observe that at the central part or entire the northern part of the Mahi Basin, there is heavy amount of rainfall, except the region which are at the mouth of the Mahi Basin. And because of this low pressure system, the large basin area receives the excess rainfall, that is above 60% rainfall. This is the one case which caused the heavy rainfall and flood in the Mahi Basin in the 1973 year. Then second example is of very well known to us, that is the flood of 26 July 2019, and this flood was mainly associated with the upper catchment area of the Krishna River Basin that covers the Satara, Sangli and Kolhapur. So here we can observe these are the low pressure systems and the truck line. This is the offshore drop, and because of this systems, very heavy to very heavy rainfall occurred in the upper catchment area of the Krishna Basin, and that caused the flood. And second cause for this is that there is more amount of water available in dams, and so the water has been released from the dam, in addition to the heavy rainfall during the storm period. This is the cloud cover for the 26th July 2009 over the India. This map, based on the rainfall record prepared for the upper catchment of the Krishna River, and here the rainfall considered from July 27 to August 7, 2019, and this is the location of the Mahabaleshwar where more than 3,000 millimeter rainfall was recorded, and the entire the upper area of the Krishna catchment received heavy rainfall during this storm period. Next is global teleconnection, that is El Nino and La Nina conditions. So El Nino is characterized by usually warm ocean temperature along the equatorial Pacific, whereas La Nina is characterized by usually cold ocean temperature in the region. And this variation from normal temperature influences the tropical Pacific Ocean atmosphere system, which in turn impacts weather and climate around the globe. The term El Nino and Southern Oscillation, that is ENSO, basically refers to both the El Nino and La Nina phenomena together. So this El Nino and La Nina significantly affect the Indian monsoon, that is known to us. But how often this phenomena occurs? El Nino and La Nina events occur on an average 2 to 7 years. Typically, El Nino occurs more frequently than La Nina. So this is the schematic diagram of the El Nino. Here we can see at the west coast of the South America, there is the warm water which cause the pressure decrease, and there is whenever the El Nino condition prevails, the South America, this area receives the heavy amount of rainfall, and its negative effect we can observe over the Indian monsoon, because around the north east of the Australia, there is pressure increases because of the cold ocean water current, and this cause there is a movement of winds from the high pressure to low pressure, and vice versa in the La Nina condition, and La Nina is favorable for the Indian monsoon. This is the real event that had occurred in the year 1997, El Nino in 1997. A large red tongue is here in equatorial Pacific, we can observe here, and this is a strong El Nino that occurred in the 1997, I mean, and heavy rainfall the South America, and the drought condition prevails over the Indian or Asian region. This is the very recent strong El Nino event of 2016. Again, a dark red patch observed in the eastern central Pacific Ocean, and here over the Indian Ocean, Bay of Bengal, Arabian Sea, we can observe the reddish color spread more. So this is the effect of El Nino. La Nina is the reverse of the El Nino. So again here the upwelling of the cold water, that is a strong Peru current, and because of this high pressure from here, and the warm water observed the east north coast of the Australia, and because of the warm water there is low pressure system, and this condition is favorable for the monsoon over the Indian territory. This is the La Nina event of 1988. Here we observe that the more blue color is spread over the central Pacific Ocean, and very less color or red color observed here. So this indicates the strong La Nina events. these are the predicted sea surface temperature anomaly conditions for different period by India Meteorology Department for the based on the 3 months moving average. This first image shows the predicted sea surface temperature for the August, September, October month. The second image represents the sea surface temperature predicted based on the for the September, October, November, and this third image shows the predicted sea surface temperature for the month of October, November, and December. So the current situation, the there is neutral ENSO condition. It means neither El Nino nor by the end of this month or the beginning of the next month, there is the La Nina condition as the sea surface temperature decreases below minus 0.5 degrees Celsius. So how does long ENSO last? So El Nino typically lasts 9 to 12 months and La Nina typically 1 to 3 years. Both tends to develop during March, June, reach peak intensity during December, April, and then weaken during May, July. However, prolonged El Nino episodes have lasted 2 years and even as long as 2 to 4 years. Then related to this, there is one more concept that is Southern Oscillation Index. So this cyclic warming and cooling of the eastern and central Pacific can be seen in the sea level pressure in the region. For example, when pressure measure at Darwin, Australia is compared with the major pressure measure at Tahiti, the difference between these two can be generated an index number. And whenever this index has a positive value, it indicates La Nina, and whenever there is a negative number, then El Nino condition it represents. So this is the graph which shows the rainfall anomaly for long term, that is from 1870 till 2015. The red color bar represent the negative rainfall anomaly, and circle filled with the yellow color represent the El Nino. So here we can observe that around 1878 or 77, there is a maximum rainfall departure from mean rainfall of the India, and it is also associated with the El Nino condition. So on the other hand, the positive departure from mean rainfall represent the high amount of rainfall, either La Nina condition or during normal condition, ENSO condition. However, there are some years represented by this yellow filled circle shows the El Nino condition. During that condition also, India receives more rainfall than normal. So this is the ENSO region. Particularly, these are the four ENSO regions: Nino 1 plus 2, Nino 3, Nino 3.4, and Nino 4 regions. So basically, for Indian monsoon, the Nino 3.4 region is considered that this region is considered, means the sea surface temperature of this area is considered. So El Nino and or La Nina is a phenomena in equatorial Pacific Ocean characterized by 5 consecutive 3 months rain mean sea surface temperature anomalies in the Nino region 3.4. So when this temperature is either above or below, it represents the whenever the value is plus 0.5 degrees Celsius, it shows the warm conditions. When the values goes decrease, that is below 0.5 degrees Celsius, it represents the cold conditions. So these are the Nino regions that defined based on their extension, latitudinal and longitudinal extension. Particularly Nino 3.4. So they consider, the meteorologists consider the sea surface temperature between 5 degrees north and south latitude, 170 degree west to 120 degree west longitude. Uh, so related to this ENSO conditions, again here I have taken one example from my research area for the Mahi basin. Here we can observe these are the index values, uh, 0.012 minus 2.5 and 0.052 plus 2.5. So this represents warm condition. The negative value represents the cold condition, and the minus 0.5 degree Celsius to plus 0.0 Celsius represent the normal condition. Likewise, the rainfall between the plus minus 10% of the mean rainfall of the Mahi basin represent the normal condition, and rainfall above the plus minus plus 10% represent the above average rainfall. Whenever the rainfall value is below the mean less than 10%, then it is below condition. So with this graph, we can observe that most of the rainfall is concentrated during the normal conditions, and this blue color dot represent the flood years, and these floods are also concentrated during the normal conditions than the cold and warm conditions. This is the rainfall statistics for the monsoon 2021. So here we can observe that for the till 4th of September, for a whole country, the rainfall shows minus 9%. So 9% less rainfall than normal. The normal rainfall as a whole is 737.8 millimeter, but actual rainfall recorded 675%. So negative rainfall, it means there is a less amount of rainfall till 4th of September. This graph also shows the same situation, that whenever there is a development of the low pressure system, rainfall observed. So particularly in the last week of the July, there was a good amount of rainfall many parts of the India because of the low pressure system associated. And this is these are the dates when Maharashtra also experienced again the flood in the upper catchment of the Krishna River basin. But there is one significant difference between this the floods which had occurred in 2019 and 2021, that the extremely heavy rainfall, or we can say the extreme rainfall events are occurred at the upper catchment area, which creates heavy amount of rainfall, and because of that there is flood condition, because a whole basin upper catchment area receives high amount of rainfall in a short period of time. And after this, after the 31st of July till the 16th or 17th August, we can observe that the rainfall is below the normal rainfall of a particular day, below the curve. This curve, green color curve line represents the normal conditions. So again, this is we can say the break in monsoon, or there is no generation of the monsoon system. This curve also represents the same conditions, that the blue line is below the red color line, which is the normal trend of the rainfall. Here also the cumulative departure rainfall of India for monsoon 2020, and again it is the below decreasing trend represent. So this is the conditions for different regions, climatic regions of India. So where we can observe the orange color represent the deficit in rainfall, whereas green color represent the normal, and blue color represent the excess rainfall. No climatic region recorded large excess rainfall. So this map represents the rainfall conditions till till 1st September 2021. So in this, Nandurbar, Buldhana, Amravati, Gondia, Gadchiroli. These districts were uh, below the uh, mean rainfall of so far seasonal rainfall, and the green color represents the normal rainfall and the blue color excess rainfall amount. Last part of this presentation is some of the techniques. So with the help of this technique, we can analyze the rainfall data, and we can generate some conclusion based on this. And these techniques are the rainfall variability, that we can understand the monsoon rainfall variability, since the variability of monsoon is one of the characteristics. Then percent departure from mean rainfall, that we have discussed with some of the graphs and maps. The rainfall trend analysis, whether the rainfall of a particular region increasing or decreasing. We can use regression analysis method. We can use Mankandal technique, t-test, sense slope analysis. Then innovative trend analysis. This is newly introduced in the 2012 by Sen. This is a normalized accumulated departure from mean. I have taken this one example from again study area, uh, that is normalized accumulated departure from mean and rainfall departure from mean. So both represent the departure from mean, but here accumulated rainfall departure is considered, and this is simply the rainfall departure from the mean. And this green color line represent the NADM. So, up to the 1930, that is from 1900 to 1930, rainfall was shows a decreasing trend. Again, 1930 to 1960, it represents the increasing trend, and again 1960 to 1990, decreasing trend. So with the help of this, we can analyze the trend and find out the causes why such type of trends are available there. Besides long-term trend, there are some slight fluctuation in the rainfall, and there are some higher or more percentage of departure from mean rainfall, particularly for example, the 2006 or 1973, because of the low pressure system, heavy rainfall observed over the Mahi Basin. This is one example for the man-candle analysis for the Mahi Basin and Narmada Basin. Rainfall was considered, that is the monsoon rainfall for the 111 years, and Z score obtained for this is 0.02. So we have to statistically check whether this value is significant at 0.0 confidence level. And for this, alpha is 1.96. Since the calculated value is 0.02, which is very much less than the significant value, statistical significant value. So there is no specific change. But in the second case, Narmada Basin, here the calculated z-score value is minus 2.82. So which is more than the statistical value, that is 1.96. And since it is a negative, so it represents a decreasing trend, and this is statistically significant. So with the help of this, we can predict the rainfall trend also. Now the concluding part, the summary of this lecture is: the monsoon origin and mechanism is a complex and dynamic in nature. Monsoon rain is a seasonal in character, which occurs between June to September. Monsoon is a result of differential rates of heating and cooling of land and sea. Low pressure systems play a significant role in monsoon rainfall distribution, amount, and intensity. Prediction of monsoon remains a challenge even after several detailed studies of atmospheric and sea surface data. Indian monsoon is affected by El Nino and southern oscillation, that is ENSO. Thank you.
Thank you, sir. The session is now open for discussion. Any queries, observations participants want to make?
Sir, may I ask a question?
Yeah, please.
Sir, very nice and informative session was this. I have one question regarding the monsoon trough, which you have explained.
Okay.
So my question is this trough a regular phenomenon during monsoon?
Yes, ma'am. And whenever there is a such type of position, we observe rainfall intensity and amount of rainfall. This is usual phenomena. Monsoon trough line it shift, and that offshore trough is more frequently than this the land trough line.
But this monsoon trough, the shifting is parallel to the normal. So what could be the reason why it is parallel to the normal?
Ma'am, it is because of the temperature variation. Uh, that's why there is the because the normal trough line, whenever there's a trough line, so it is a low pressure area. But both side of the trough line, the pressure slowly increases, and there is thermal difference also temperature also that particular region. So that could be a cause of shift in north south of the normal position.
But it doesn't seem scattered all over the country because we are having different heating and cooling of the land and water. So it should be scattered all over the country. But it is not seen. It is parallel to the trough. Sorry,
Yes,
parallel to the normal.
it is just like, say, for example, uh, the shifting of the intertropical convergence. Actually, these trough lines are the, we can see the extreme part of the ITCZ, that is, which shift northward and southward with respect to the temperature and the movement of the sun migration. And this is the extreme part of the ITCZ. Right now, I don't have that figure to show you. And in order to avoid the confusion, I have used only monsoon trough word here, but it is a part of the ITCZ.
Okay. Okay. Thank you, sir. I have one more question
Yeah, ma'am,
regarding
please.
El Nino and La Nina. So whenever these situations are occurring in the ocean, see the distance between Australia and India or Asia, the geographical distance is too vast. So
Hmm.
whenever this situation is occurred and when these oscillation is traveling towards the west, so doesn't it cool down in the middle, considering the geographical distance between these two continents?
But which La Nina or El Nino?
In both the figures, it is shown that it generates from South America along
Actually,
the west coast of South America.
first thing we have to make clear that El Nino and La Nina, these are the ocean currents. First thing, and because of there is increasing sea surface temperature, and that cause the heating of the that is the atmosphere. So it is interaction between ocean and atmosphere. So, and we can study, or even we have seen that the these currents travel a longer distance. So, and when there is characteristic, whenever the warm ocean currents they reach to the polar area, they increase the sea surface temperature where they reach, and the cold ocean currents where they reach to the area, they decrease the temperature, sea surface temperature of the particular, and as a result of that, there is development of the high pressure and low pressure system because of the sea surface air, which are very close to the lower layers of the air column.
Okay, thank you, sir.
Any more?
Yeah,
Yeah, please.
since last 5 years, there is drastical changes in rainfall of Maharashtra.
Mm.
Unexpectedly, some regions having the heavier rainfall as like cloud burst. So, what are the basic reasons behind it?
Yes. First thing, for 5 years, and you have said that change. Whenever we are talking the change in terms of the climate, this 5 years, 20 years change. It is not acceptable. First thing, according to me, and it is as per the when we use the definition of climatic, at least 30 years, even 30 years data. First thing. Second thing, we don't have a continuous record for a whole area, say for last 100 years and 110 years record. So, and why this situation prevail? So very recently, 2019 flood is there, then 2021 flood is there. If you compare these two floods, these are associated with the low pressure systems, and we can predict El Nino, La Nina situation much before. But these low pressure systems, whenever develop, their track and their intensity that affect the rainfall distribution. And in both the cases, 2019 flood and 2020 21, so these systems are responsible, and they have one characteristic that they give heavy rainfall, high intensity rainfall over a short period of time. So that is first thing. Second things, then we have to study such extreme events, whether the number of rainy days, or we can say the normal distribution of rainfall is changing, and the extreme rainfall events increasing, that they have to study, but not on the basis of last 5 years, 10 years. We should have long-term record. Then we can analyze its trend.
हॅलो सर.
Yes, sir.
सर तुम्ही साऊथ केरळापासून ते गुजरातपर्यंत ट्रप दाखवलेला होता डायग्राम मध्ये.
हो.
तर ऍक्च्युअली बॅरियर वेस्टर्न घाट आहे, त्यामुळे ओरोग्राफिक रेनफॉल होतो.
हो हो.
मग नक्की कशामुळे रेनफॉल होण्याचे चान्सेस जास्त असतात, ट्रपमुळे का बॅरियरमुळे?
नाही. जर आपण कोस्टल एरियाचा विचार केला तर काय होतं, ही ट्रप लाईनचं कॅरेक्टरिस्टिक काय आहे का, ट्रप म्हणजे लो प्रेशरचा लाईन अलॉंग दॅट लाईन, लो प्रेशर जनरेट. आणि साधारणतः विंड जे आहेत ते हाय प्रेशर कडनं कम्पॅरेटिव्हली हाय प्रेशर कडनं लो प्रेशर कडे वाहतात. आणि ते जे विंड आहेत वेस्टवर्ड विंड दॅट ब्लोईंग ओव्हर दी अरेबियन सी, ते कॅरीज हेवी लोड ऑफ मॉइश्चर. And when the winds blows over the coastal belt of the coastal west coast region, then they move towards the mainland of India, and then there is a upslope movement of the wind, and then again the same process, the high amount of rainfall observed on the windward side, and then moisture loss, and leeward side there is less rainfall, and that we call rain shadow zone. So here both the parameter are responsible for heavy rain, but the trough line that drags the moisture laden wind towards the particular region.
Thank you, sir.
Any more questions?
Yeah, can we have the official vote of thanks, please?
Hello. Hello.
Hello.
Sir, can I start vote of thanks?
Yes, please.
Okay, sir. Thank you. Good evening, all. Here, I would like to take an opportunity to express vote of thanks on the behalf of host, Department of Geography, Sir Parshuram Bhau College, Pune. Sir, in his session, beautifully explained all the conceptual and practical oriented perspective on Indian monsoon. It was really one of the best demonstration throughout this PhD coursework. Sir has covered all the aspects on Indian monsoon, such as meaning, origin, mechanism, factors influencing on Indian monsoon, weather forecast, synoptic conditions and rainfall, global telecommunication law, and El Nino. Monsoon 2020-21, and various methods of rainfall data analysis. We are all extremely grateful to you, sir. Thanks once again for enlightening us. I would like to extend my thanks towards our principal, Dr. Savita Datar Madam, for his continuous supports and guidance. I would like to express gratitude towards Head of Department, Dr. Sunil Gaikwad sir, for his valuable guidance and support throughout the program. I further extend my gratitude and sincere thanks to our course coordinator, Dr. Manojkumar Devne sir, for giving us this great opportunity to enrich ourselves through this academic enrichment program, that is PhD coursework program. I would like to say thanks to our very active and attendable all-time co-coordinator, Dr. Ganesh Dawale sir. I would like to say thanks to entire organizing team and technical team of PhD coursework, and last but not least, all the dear participants of for your active participation. Thank you very much.